Alan Bassindale is an emeritus professor of chemistry and former pro-vice chancellor of the Open University. He has a long-standing interest in the history of science. Let me hand over to Alan.
Well, thank you very much. Very kind introduction. It's also a terrific pleasure to be able to talk to both BRLSI Science and the Herschel Society, two very august bodies in what is now my hometown of Bath. I've had a long-standing interest in Robert Hooke. He's often known for Hooke's law, which many of us who did O-level physics will have enjoyed because it's absolutely linear. It's a sort of y equals mx law, so it's fairly easy to do calculations. So I liked him from the start. But also, what I've learned since in studying Hooke is that I believe that he was one of the major figures in helping us to change from the previous Aristotelian type view of the universe where thought was more important and reason was more important than experiment. And he's helped to change that so that we have now got experiment and we've got the scientific method. And I'll hope to show you how he contributed to that. Of course, I'm not saying one person, man, woman, can do everything. And as I'll talk about later, standing on the shoulders of giants is what we do in science. So Hooke was born on the Isle of Wight, 1635, died 1705. So it's a historical talk. This is how I'm going to structure the talk. A little bit about background and context, how he was a major influence, not just on science, but art, technology, and knowledge, and scientific method, etc. And Sir Isaac Newton comes up, his difficult relationship with Newton. It's really important to understand that because Newton was the genius of geniuses, really. He was perhaps the most accomplished scientist that ever lived, but he was also quite difficult. Hooke is supposed to be, by many accounts, the most accomplished experimental scientist ever. So there's a clash there of philosophies as well as anything else. Now, I'm going to talk mainly about microscopy and astronomy. They both use lenses, so that's one possible connection between the two, but one leads into the other with Robert Hooke because he started with microscopy and then he moved on to astronomy. And I shall mention the Herschel connection there. But I'll finish with his contribution to knowledge and but also mention his lack of public recognition over about 300 years. So he was not just half forgotten, he was forgotten for a lot of that. Now, there is a monster amount of papers and books on Robert Hooke, but they're mostly rather specialist and for people like me who are very interested, that he doesn't come across to the general public in the way that, say, Newton does. He was born, as I said, on the Isle of Wight. This is a 1610 map, so he was born in 1635, and this is roughly what the island was supposed to look like at the time. The very deep, the aquamarine blue shows Freshwater Bay, and he was born in Freshwater, which is obviously just above the bay. So that part of the island was rather wild and rugged. And I'll come back to that, but this explains part of my interest in Hooke. I worked in the Robert Hooke laboratories at the Open University, it was opened actually by the Astronomer Royal at the time, and he mentioned this church that we know very well because we live quite close to it. It's Willen Church, it's a Grade 1 church, and it was designed by Robert Hooke, who was a formidable architect as well. I haven't included them, but I've got on the show a couple of his buildings because he and Wren were both brilliant architects. So this is another reason why I was interested. Everywhere I moved, I seemed to fall over Robert Hooke, from O-level science to living in Milton Keynes for a while. Now this beautiful building is where he was born. and you won't be surprised to hear that it's actually been demolished now. That photograph is from about 1902, I think, very early photograph. And there is this, I have to say, slightly curious monument to Robert Hooke, right on the spot, or near the spot where his house was. The significance has so far escaped me, so any illumination would be gratefully received here. But it does, it's on Hooke Hill, so they've renamed the road on which he was born as Hooke Hill. So he's not forgotten on the Isle of Wight. And the Isle of Wight has a Robert Hooke Society, and they've produced a very nice little booklet which has got this trail in it, and it's got descriptions of where things that were significant for Robert Hooke. It's a very nice walk, and they've got a very good website if you want to know more. Look at the Robert Hooke Society. We had a very nice walk not so long ago up Tennyson's Down, for those of you that know the Isle of Wight. Beautiful walk, looking down on freshwater, and the little church in the sort of toppish left-hand corner, that's All Saints' Church, where his father was the perpetual curate. Now, this environment in which he lived was fantastic for a kid with interests and curiosity about nature, because all of nature was here: freshwater, seawater, marshes, birds, everything. And what's more, within a very short walk, he could go down to the sea, and this is the view from freshwater towards Compton Bay. You can see also in the rocks there that there are strata, and he talked about strata, precursor of William Strata Smith. But between those two rocks is Compton Bay. Now, if you're interested in fossils, Compton Bay is absolutely heaving, teeming with fossils. It's a wonderful place, and Hooke used to go there quite a lot. Now, there is no portrait of Robert Hooke, but there's an artist called Rita Greer, who was actually stimulated by Alan Chapman, who I believe 15 years ago, for those of you with long memories, gave a lecture here on Robert Hooke. And he wrote an article, and Rita, who I've met and is a very nice person, decided to commemorate Hooke by a series of portraits. She's done lots from her imagination. This is the first in the series because it's him as a 12-year-old boy standing in Compton Bay looking towards freshwater with an ammonite in his hand. So it's already expressing some of the interest that he had as a boy. Before I talk about his accomplishments, I want to try and paint a picture of him so that you've got an idea of what he was like, who he was, the age he lived in, to give some context. Well, born in freshwater, when he was aged 13, his father died. Slightly strange circumstances, but nobody knows exactly what happened, but he died, and he'd already arranged for Robert, who was a fairly sickly child, which I'll come on to get an apprenticeship with the famous portrait painter Peter Lely, who became Sir Peter Lely. So he went to work with Lely in London, took himself off with his, I believe he had about £60 to his name when he went to London, but he didn't like the smell of the paint in Lely's studios, and I think he was being given menial tasks to do. So we don't know quite how, but he took himself off to Westminster School, and the headmaster there, 60 years head, very famous head, Dr. Busby, took him under his wing, lodged him in Busby's house along with some of the other scholars, and he had apparently a great time at Westminster. He very rarely went to lessons. He was very much an autodidact, was Hooke, or like an Open University student, a sort of supported autodidact. But he spent a lot of time working on lathes, building things. He was incredibly accomplished with his hands. He made things. When he was about 9 or 10, he built a boat that he sailed on the water near his home, and it had working cannons that he could fire. I mean, you know, this is a kid. I mean, thank goodness they wasn't bigger. So he was always interested in making things. Then 1653, probably facilitated by Busby, he went up to Christchurch, which I think has long-standing arrangements with Westminster. Now this is a slight connection with Herschel in that he was a choral scholar and an organist. Now this was the time of the Commonwealth, so choral scholar was slightly meaningless as they banned choirs in churches, but he was a choral scholar. And there, the absolutely stellar people that he met, Robert Boyle, who was a lifelong friend of his, father of chemistry, wrote Skeptical Chemist, Thomas Willis, who was a physiologist, who worked with Hooke, John Wilkins, who was the master of Wadham and had the good fortune during the time of the Commonwealth and beyond to have married Oliver Cromwell's sister. So that helped him along a little bit, I think. He was a bishop as well. Christopher Wren, we all know about Wren as an architect, but actually Wren was a fantastic mathematician and astronomer as well. But he gave it all up for architecture, whereas Hooke continued to try and do everything. And John Locke, philosopher, and many others. But these are the founders of the Royal Society in 1660. Hooke wasn't a founder of the Royal Society, and his status as a servitor at Oxford perhaps explains why. Poor scholars were not able, had to earn their keep by being a servant, essentially, to another student with lots of money or a member of staff. And Hooke was a servitor, and he always felt that he had this slightly inferior status. He was a middle-class boy among all these aristocrats. Robert Boyle, as an undergraduate, seventh son of an earl, had been given so much land that he had an income in 1653 of 20,000 a year, which wasn't bad. So he was among all these wealthy aristocrats, and that didn't help his status because he was always doing something for other people. And this is an example. 2 years after the Royal was founded, he was appointed curator of experiments. That meant he had to do an experiment, new experiment every week. Sometimes it was horrible, like vivisection, and sometimes it was showing microscope, what he'd seen through a microscope. And often they were dictated by the fellows. And that was slightly tricky because some of the fellows had slightly crazy ideas, but he had to fulfill them, which he did. His talent was soon really made manifest by, according to the fellows, and he was elected FRS in 1663. The Royal couldn't afford to keep paying him as curator as much as they wanted to, and Wren was professor of astronomy at Gresham College. Now, Gresham College was founded in 1597 by Sir Thomas Gresham for the dissemination of new knowledge to the public. And it's still going, and they still have professors who give talks to the public. And he was appointed professor of geometry, probably because it was vacant rather than because of his skill in geometry. Although he did master the first 6 books of Euclid in his first 2 weeks at Westminster, of Euclid's geometry. So he had some talent there. He lived in Gresham College as well for the rest of his life. They gave him lodgings. After the fire, the Great Fire of London, he was appointed surveyor on post-fire reconstruction. He was apparently wonderful at surveying, and he managed to get London rebuilt because what he did was, Wren wanted to knock everything down and build this grand new city, whereas Hooke said, too complicated. People have got deeds to their land, or the 17th century equivalent. I'm going to build on the plots, or we're going to arrange. So he surveyed everybody's plots, and he did a wonderful job. And London wouldn't have been built as it is without, well, a combination of Hooke and Wren. He died in 1703 in London. So what times did he live in? I mean, I don't want to linger on this, but we live in turbulent times. I think we'd all agree that. But this was 5 kings and a queen, civil wars, Commonwealth Protectorate and Rump Parliament. So politically, and I didn't mention here, but Catholic, Protestant, etc. And he lived through the Scientific Revolution or the end of it, Restoration, Age of Enlightenment. And these all express massive amount of intellectual excitement. But in the middle of all this was the Great Plague, where 100,000 Londoners died. That was 25% of the population. He took himself off to a place called Durbans near Epsom with Wilkins, Bishop Wilkins, the master of Wadham, and apparently they had a fine old time and inventing things, doing scientific experiments. And Samuel Pepys, a friend of theirs, came along and joined in sometimes. And then not only was the plague, the fire of London followed, 13,000 houses and 86 churches, and that's after that he became the surveyor. Now I wanted to try and express the breadth of his interests and achievements, and I thought, how about an A to Z? And I got everything except X, because X-rays hadn't been discovered then. And my daughter suggested exceptional, and maybe I should have put that in. But he did all these things. He was interested in navigation. He looked at Jupiter's, thought he'd seen the red spot, but there might be some doubt. He made a camera obscura, philosophy. The ones in red I'm going to touch on today: astronomy, art, experiments, instruments, lights, and those sorts of things. No need to dwell on this, but just to show you that he was the polymath's polymath, really. He wrote papers and achievements in all these fields. So what was he like? Well, this is a bit sad in a way. Nobody could say a good word about his appearance. John Evelyn, was the best description, said that he was eyes full and popping, high forehead, and just nothing was particularly attractive. So he was clearly not very attractive. But part of that was also, he suffered ill health all his life. In fact, the reason he was homeschooled in Freshwater was his father didn't think he was going to live long enough to justify the school fees, I think. So he stayed at home and was homeschooled. But he also had quite a severe curvature of the spine that developed more and more as he lived on. And he also was subject to bouts of depression. So it's incredible that he got things done and made things. He was extremely friendly, cooperative and sociable. He was liked by all. He used to go to coffee houses an awful lot with Wren and all sorts of those other people, Samuel Pepys. But also, he was always interested in craftsmen because he made things. He had great friendships with craftsmen. Perhaps the most difficult part of his personality these days is that he was unmarried, but his great love of his life was his niece Grace. And it's quite clear from his diaries, which I haven't mentioned yet, that he actually had sex of some form. Fortunately, we don't get the gory details, but he did have sex with his niece on fairly regular occurrences. And she also had relationships with other men, which he didn't like very much. But then he had relationships with his other servants. So it was a kind of free and easy restoration drama, I believe. His diaries are interesting because they weren't meant for publication. What they are is an account of his day-to-day doings in note form, but also his health. He sort of experimented on himself. And he tells you every ache, pain, bowel movement, orgasm, you name it. He writes it all down, and he tells you all about the cures that he tried to use to effect this. And there is a thought that probably it was the cures that killed him in the end. He was quick to anger. He had a fairly mercurial, but he was also quick to forget, unlike Newton, who's coming up. One thing that annoyed his contemporaries was that he claimed, somebody would say, I've invented a balance spring for a watch, and Hooke would say, oh, I did that 20 years ago. And he kept saying these things, and people thought that he was a bit of a, I was trying to think of a polite way of saying it, a lot of bull. But when his posthumous papers, which came to light clearly after he died, show that he had done many of the things that he claimed to have done, he just hadn't published them. He hadn't written them up in a form that people could understand. So he was his own worst enemy in that. He wasn't a completer finisher. Now, Newton, briefly. Many people know that Newton said, if I have seen further, it's by standing on the shoulders of giants. And this is in a letter of 1675 to Newton, from Newton to Hooke. And Newton was only 32 years old when he wrote this, but my opinion of Newton is that he makes Moses look flexible and open to argument. When Newton said something, it was said. If he said that the world is square, then the world was square, and you didn't need to test it because Newton had said so, until he changed his mind. And Newton and Hooke, one of the reasons why they had such a falling out was that they were both working on the two hottest topics of the 17th century, and that was light and color and gravity, light and color being the same, and gravity, and they had different views. And this letter here is about, basically about the inverse square law of gravity. And it was the beginning of a major, major fallout between the two of them. And you don't take on Newton lightly, and I'm afraid Hooke lost, as we will see. So where did it all start? Let's look at his achievements. He designed an air pump for Robert Boyle. He did this as an undergraduate. People had tried to make vacuums for years for doing experiments, and they hadn't been able to. And this 19-year-old undergraduate decided that they'd been doing it wrong, and I can make a nice air pump that'll make a good vacuum. And he made all sorts of innovations, like sealing the vacuum with what he calls salad oil. So he used an oil to seal the joints. And this got a very, very, very respectable vacuum, actually. And this is what Boyle used for Boyle's law, that pressure times volume is a constant, or pressure is inversely proportional to volume. And this is, I'm never quite sure in the Science Museum whether it's a replica or one that's actual, but I think this may be Hooke's own air pump. So let's go on to microscopy. In the 1660s, microscopy was really quite new. Beginning of the 1600s, microscopes had been invented, or usable ones. And at Oxford, with Willis and Wren, they started making microscopes and looking through them. They were compound microscopes with about a 40 to 50 magnification. And as curator of experiments, because it was new, people wanted him to do microscopic work. So he used, these are two microscopes that either replicas or actuals of Hooke's. The one on the left is by Richard Reeve, and he used Richard Reeve to build them first, and he was slightly friendly with him, but then Reeve slightly blotted his copybook by murdering his wife and then buying a pardon from Charles II. And I think Hooke decided that that was enough of Richard Reeve, and he started working with Christopher Cock, who he called Christopher Cook, but Cock is his actual name. And they had a very long friendship and productive partnership making these microscopes, which were kind of, wobbly. They're very little. They're only about this big. And all of his work was published in, well, not all of it, but a lot of his microscopic work was published in Micrographia, which is descriptions of minute bodies made by magnifying glasses with observations and inquiries thereupon. That's the key for me. It's not just looking at them. He looks at things and then he observes and then he makes a hypothesis. How did that happen? How can I test it? What can I do? Can I do an experiment? So, and it's all written up in Micrographia. It's absolutely brilliant book. This particular photograph is from the Royal Society's edition, copy, but there is one in the Bath Record Office. And it's a wonderful book, and I felt so privileged. In the Royal Society, it's in a case, and you can't actually touch it unless you're very special. Whereas at the Record Office, they did allow me to look at it and turn the pages, and unfortunately, I had to tell them, which they didn't know, that 2 pages, the most famous pages, the flea and the fly, had been cut out of Bath's copy. And it's probably worth £100,000 if it's complete, and it's a very wonderful edition. But I don't know if it's not worthless, but it won't be worth anything like that. So it's got a preface, and he talks about, in the preface, all about the senses, trying to make us understand that it's not about thought processes, it's about what we perceive. But he also goes on to say that perception, I'm paraphrasing, but perception is individual. And sometimes 2 people can see the same thing and make different inferences from it. And this was quite an important observation, that even experiments aren't completely objective and that one has to filter them through some sort of lens or another. So it's a philosophical, artistic, it's a model of organization and logic, is this book. I think it's one of the top 3 books ever in science, alongside Principia by Newton and Darwin's Evolution. So it starts, this is the first illustration of and you'll possibly see the logic of it. It starts with a full stop, no dimensions. It moves on to a razor's edge at the bottom, 1 dimension, and then it goes on to, you can take it as either 2 or 3 dimensions with the head of a pin. These diagrams themselves were all revelations to the 17th century mind. A full stop, a dot, is not perfect sphere. It's ragged on the edges. A razor looks as if you wouldn't really want to use that because of all the lumps and bumps in it. And then he organizes the book by starting with inanimate objects, cloths, snowflakes, other inanimate objects. Then he moves on to plants and animals. And finally, he looks at some telescopic ones. It's about lenses again, and the moon, planets and the moon by telescope. This is a very poignant illustration from it. It's called gravel in urine, and we've now identified these crystals as ammonium magnesium phosphate hexahydrate and orthorhombic crystals. Whoops. But what he's done here, the little circles are trying to show how you can make different shapes from circular, spherical building blocks. Now, this is exactly what we do in crystallography now with our students. If we want to show the structure of a metal, we'll say it's spheres, AB, AB, ABC, however, packed like that. And if you think about, many of you might remember, how to make a pyramid out of spheres, well, Ferrero Rocher springs to mind. And that's the sort of packing that he was interested in. I don't think he had Ferrero Rocher, but he did the packing. But the other thing about this is that he probably got these crystals, I think he said, by scraping a lavatory bowl. Now, he would go to great lengths to carry out his experiments. And this didn't escape the notice of one Thomas Shadwell, a Restoration playwright, who wrote a play called The Virtuoso. It's about a completely bonkers scientist, clearly based on Robert Hooke, and his name was Sir Nicholas Gimcrack. And Hooke was persuaded to go and see the play, and when he went, he was mortified because the P was being taken out of him rather literally here, and he assumed that people would think his legacy was looking at things in urine, and also another of his slides is drawings is eels in vinegar, and Shadwell mercilessly satirizes those. And Hooke was so devastated, I think he stayed in bed for a couple of days after doing that, seeing that. Back to real science and interesting things. He looked at cork bark and he found these cells, these holes, and they reminded him of monks' cells. And so he called them cells, but he thought these look like building blocks. And he went on to postulate that all plants had cells. Now that was very prescient, because we know now that the cell is one of the basic building blocks of biology, and this was the first time that was expressed. So this is another non-completer finisher. Great idea, let's move on. I've included this drawing just because I like it really, and it shows the precision with which he could draw using that microscope. He had one eye on the objective lens, the other eye open, with his notebook, writing, doing these drawings. This is a compound eye of a fly, and you can see it's absolutely incredibly detailed and very accurate too. For those of you that know, when you look at it, you can actually see Fibonacci patterns, which is like the packing of a sunflower head. When you look at that, you can see lines going that way and that way. So although he didn't explicitly mention Fibonacci, he observed it well enough. So this is the flea. This is the one that's missing from the Bath one, and this is the one that people will know if they know anything from Micrographia. It will be this one. It's particularly poignant because Micrographia was published in 1665, published in the plague year, and the biggest diagram in his book is the flea, and they didn't know, but the flea is almost certainly, was well considered to be the vector for the bubonic plague. So he got this big picture of a flea. It maps directly onto photographs of fleas now that we can do now. It's again so accurate, down to the hairs and everything. And there is an art critic called Jonathan Jones who has written a book claiming that this is the precursor of much of British art. Now, how does he work that out? Well, he says that it's the first time that there's a dialogue between art and science. So this is not just a pretty picture, it's actually art, and he's got light and shade, and it's naturalistic art. And he goes on to say it's not all British art, but he says that the art of Stubbs, with those beautiful anatomical details, and even Damien Hirst and his rotting cow's head with flies, derives from this sort of naturalistic diagram. Now, I think it's a bit of a long shot, but it was interesting to read. Now, in view of the exhibition in the foyer, included some of his fossil work. Now, it says downstairs, it doesn't mention Robert Hooke, but it says Leonardo had theories about fossils, which I confess I didn't know. But Hooke's illustration of echinoids, sea urchins, and a nautilus up at the top there. Now, the echinoid, I happen to have an echinoid here that I picked up on Compton Beach, so it's almost identical to his drawing. Uninformed opinion at the time believed that when the Earth moved, there was some sort of plastic quality of the Earth that shaped these stones. Nobody really knew how, or even thought to think how, but they had these stones were formed. But he said, no, they belong to living things, and they were petrified by petrifying water or mud or something which filled the pores and made them by some process into stone. He also said some of them are no longer visible on Earth, no longer living on Earth, but they look like some things that are. So maybe things have developed one from the other. So this was a very early idea of evolution. So Microscopical observations, improved microscopes, nature hidden from us by virtue of its size revealed, greater understanding of matter at the fundamental level. And I haven't dwelt on it, but every observation he makes a hypothesis and suggests some experiments in the book. And again, the primacy of Baconian and Cartesians, Descartes, experimental philosophy was asserted over systems where thought and reasoning was more important than evidence. This was a movement that wasn't just Hooke. If you know the Royal Society, you'll know that their motto is nullius in verba, which means take nobody's word for it. And that actually comes from Horace, but the Royal Society was explicitly Baconian in its approach. Bacon said that one had to do experiments to understand the world. So now, astronomy. This was another cause of dispute between Hooke and Newton, because astronomy is about they're using to try to understand gravity, and he made most of his observations using a simple refractor telescope, a lens at each end. He wanted to prove that the Earth went round the sun, rather than the Earth being the center of the universe. It was well accepted by then, but there was no experimental proof. And it's only the year that Hooke was born, well, 5 years before Hooke was born, Galileo was forced to recant by the Inquisition and say that the Earth was at the center of the world. But his dying words were apparently, "But it moves." So if you want to build a big telescope and you want to stay in the warm, why not knock a hole through your roof and bung a telescope right up through it and have at the bottom, the little sort of square at the bottom of that, that's a cross-section of his house drawn by Hooke. There's a table, a little lens, and he can lie on his duvet and look up and make measurements with one eye and do drawings with the other. So he hoped that parallax measurements would prove that the Earth orbits the sun. Parallax is simply a change in position according to a change in the observer's position, the change of an object's position as the observer changes position. Usually one says parallax can be understood by lifting a finger up, closing one eye, looking at an object, closing that eye and opening the other, and the finger appears to move. That's parallax. So he thought, if we're at the center of the universe, we look up, it's a zenith telescope, you get the least atmosphere if you look straight up, and you look at this star called Gamma Draconis, and if it stays exactly where it is, and all the other stars stay where they are, then we're at the center of the universe. But if we move a little, our perspective changes, and that appears to change. So he was looking for minute changes in the position. This is the first time, as I understand it, that parallax was used to try to understand the nature of distant stars and the nature of the Earth. Unfortunately, it didn't work terribly well because the errors by wobble were far greater than the movement. I'll just show you a picture very quickly. This is Gresham College, and he lived in the top right-hand corner of the courtyard there. Let's blow it up a bit. And this was an illustration from 1739, after he'd been dead for 30 years, but his telescope is still on the roof of Gresham College, which is now demolished. And the arrow points to it, number 8 on the slide. And there's his lodgings. The garret on the right was probably Grace's when she was able to sleep by herself. So this was where he lived. It's wonderful actually to have a picture of his lodgings because they've been demolished. He didn't give up on parallax. After the Great Fire of London, I said that he was the surveyor, and he and Wren were commissioned to build a monument to the Great Fire of London. And this particular monument is, well, it's called the monument, and I climbed up it as a kid. I'm not sure I could manage now. I think it's 360 steps, and it's 61.6 meters high, and it's 61.6 meters away from the actual spot in Pudding Lane where the Great Fire of London started. So it is a monument, but Hooke and Wren were more interested actually in it being a scientific instrument. So it's another zenith telescope looking straight up to Gamma Draconis, this particular star which is right at the zenith, and they tried to use that. And again, it's got a nice little bed down at the bottom to lie there and have a look. And I didn't mention, but this and the Gresham College one have got a flap. He could sit in his house, pull the flap so that it lifted up so that the rain didn't get in, and he could see straight up into the sky when he wanted to. But for somebody who was known for the laws of elasticity, it didn't seem to have occurred to he or Wren that even a 61.6 meter tower is going to move a little with wind. Well, the underground, the tube wasn't there at the time, but passing horses and carts, just enough to wobble. Again, we're talking about 20 arc seconds, which is absolutely minute. He did invent micrometers to try to measure such small distances and angles, but again, the errors were too big. But it's a monument to the plague, and it's a monument to Hooke and Wren's inventiveness. I'll move on now to his actual telescopic. This is in Micrographia, but these are the craters on the moon. There's stars in Pleiades there. I'm not going to talk about those. Just the picture of the moon. And significant for two reasons, really, or more possibly. One is that this diagram can be mapped onto a diagram of the moon now. In fact, Alan Chapman at Oxford commissioned some students to try and find this particular arrangement on the moon using current maps of the moon, and they found it, and it's very, very accurate again. But also you can see, when you look at the craters, that he's put the shadows in, because that's what he observed. That made him know that they were craters and not just round features. And the reasoning was wrong, but his conclusion was that these craters showed that the moon had a gravity. That was not always thought to be the case. They thought in those days that the ether, which was swirling around, it was ill-defined, and that was carrying the moon around with it. But he said, no, the moon has gravity, and it behaves like everything else. Now, I wish my lab notebooks had been this neat and tidy. It's beautiful. This is observations of Mars that he has done himself, and this is his notebook, although for some reason he spells his name without the terminal E. Sometimes he did, sometimes he didn't. And these have got features on the surface of Mars that in 1862, there was a Dutchman called Kaiser used these diagrams and a few others from other people to calculate the period of rotation of Mars. And Kaiser got it to be, using these, to be about 24 hours and a half, roughly, but he did it exactly. And that was within 1/10 of a second of what we understand it to be now. So again, fantastic accuracy. All of his astronomical observations led him to three suppositions. I'm not sure whether I need to go over these in detail, but they are related to Kepler's laws of motion and Newton's laws. They after Kepler, but before Newton. All celestial bodies have gravitational attraction, so a universal law of gravitational attraction. Bodies going in a straight line will continue in that line until another force acts on them. And if it's the force of gravity, it could pull a planet into an elliptical orbit. And the third one says that the further apart two objects are, the less the gravitational attraction is. And he, in 1680, he told Newton about the inverse square law, which says that if you double the distance, you get a quarter of the attraction. treble the distance, you get a ninth of the attraction. So it's an inverse square law. And he said, I don't know how to show this maps onto elliptical orbits, but you're the man to do it. And Newton said, I'm not interested, and then went away and did it, and then said he'd done it in 1660. So, and he never credited him. Now this is where we get one of the Herschel links, apart from the music, which Herschel and Hooke were, that the future of telescopes wasn't the refractor, it was the reflector. And again, I won't bother with the paths here, but there was a mathematician, a Scottish mathematician called Gregory, who invented the Gregorian telescope, but he didn't have the skills to do it. Now, Hooke was somebody who had the fantastic technical skills that enabled him to turn other people's dreams and sketches into reality. And that's what he did. He built the Gregorian telescope, which was a reflector. But as those of you who know about this period will know, actually, Newton got there first and made a reflector telescope. But this one is different from Newton's in that the observer, the red spot, is actually looking where the stars are. With a Newtonian telescope, you look in through the side because he's got mirrors. And these mirrors rather, are made of a metal called speculum, which is 2 copper to tin. And if you want to see how to make speculum metal, go to the Herschel Museum and look in the basement, and you'll see these wonderful bits of kit where he made them. And you'll also see how Herschel polished the speculum metal to make the mirrors. I mean, they are incredible. There's still a couple there now. So the reflector telescope had the advantage it ruled out chromatic aberration. Now, if you've done any look through cheap binoculars or telescopes, you'll know that the fringes around the outside are multicolored. That's chromatic aberration. If you use a polished mirror, you lose that. So it lost, and it also enabled you to have a smaller telescope for a longer focal length. So it had 2 advantages, and you also could have a bigger aperture and get more light in. So the future of astronomy was the reflector telescope. Now, Herschel claims in the Science Museum that Herschel made this telescope. Again, whether it's a model, I wouldn't really like to say, but it says it's Herschel's. Herschel was the first professional astronomer to use a reflector telescope. And he used that, as you all know, to map the deep sky and discover Uranus and all the other wonderful things that Herschel did. And Hooke had been instrumental in helping to make reflectors popular because he was better at making mirrors than Newton. Newton's mirrors clouded up after a little while, whereas Hooke, because he was a wonderful experimentalist, and Newton made his own telescope, by the way, as well. But Hooke was better at making this speculum metal. So what's the impact of his astronomical observations? Better telescopes, parallax established as a method for examining celestial bodies. Didn't talk about it, but he looked a lot at comets. He and Newton argued again about comets and their explanation. Why did they go one way? What was the tale all about? He observed craters on the moon, mapped them beautifully. He demonstrated the rotation of Mars. He showed that Jupiter had belts and spots. Many people claim that he was the first to see the red spot, but that's disputed, that what he was seeing was another storm on Jupiter. He also made a helioscope, because you can't look at the sun with a telescope, not if you want to keep your vision. So he invented a helioscope for projecting the sun, and he was first to observe sunspots, I believe. His 3 suppositions form the basis of an understanding of the universe. Now, the mechanical universe. Newton formalized it in ways that Hooke couldn't have done, but Hooke set the foundations here, the shoulders on which the giant stood. So, last few minutes, look at his main contributions to science, philosophy, and art. sometimes said to anticipate later discoveries, evolution, etc. He described the mechanical universe. He developed experimental methodologies, used hypotheses, developed the modern scientific method. Haven't mentioned, but wave theory of light and vibrations. He believed that everything was in motion and that vibrations were the driving force for sound, light, earth movements, everything in motion. Did a lot of work on that as well, actually. Early ideas on evolution. He understood that the observer is integral to the experiment. I mean, if you do quantum mechanics these days, you can't, there's no such thing as no observer, and it's critical. Numerous mechanical inventions. He invented the universal joint, watch balance spring, anchor escapement, all sorts of things I haven't got time for. He introduced naturalistic art, and he was instrumental in rebuilding London. Not a bad legacy, I'd say. But why isn't he more widely celebrated? Well, it is this middle-class background. He didn't have the same status as Wren and all the others, and many in the Royal Society still looked down on him, even though they recognized him as a genius. And he was often subject to others. And also, he lived in a time, an incredible time. The intellectual atmosphere, it must have been completely fervid in Oxford in the 1660s and in London in the 1660s. All these wonderful people around him. And he didn't actually leave, apart from Micrographia, a whole series of coherent papers. I'll come to that in a moment. And people thought he was a great inventor rather than a great thinker. Well, my view is that he was probably a greater thinker than he was inventor. Also, Newton changed the narrative. Maths-based science displaced experimental discovery as the paradigm. So if you couldn't express it mathematically, in the late 1600s, then it probably wasn't real science. And Newton, I'm afraid this is true, that when Hooke died, Newton became president of the Royal Society, and he systematically trashed Hooke's reputation, and he also put all his beautifully made bits of kit into the basement, let them rot, and he didn't get Hooke's papers catalogued, he just let them all go. So Newton really tried to diminish his reputation, and it worked for 300 years. Now this is just a little amusing to me anyway, aside. That's a picture of Robert Hooke by Rita Greer in the top right. And Anna, my wife, and I were in Klaipėda in Lithuania, as you are, you know, and we went to the Clock and Watch Museum. And there, in this cabinet, was a picture of Robert Hooke and a description of his invention of the balance spring. I thought that was really interesting. I tried to get a better picture, or Anna tried to get them to close the curtains so that it was better light, but it was a bit like being back in Soviet Russia, and that, no, more than my job's worth to close the curtains. No, can't do it. Anyway, if you're ever in Klaipėda, it's worth a visit. So I'm going to finish by just showing another of Rita Greer's pictures of him with all sorts of his inventions around him, and his microscope, fossils, and all the rest of it, and say thank you very much for your attention, and I'm happy to answer any questions I can. Thank you.
Right, we'll start off taking questions in the room, and then we'll go and see if there are any in the chat channel. We've got about 16 people online, I think.
You said that with all these geniuses around the mid-17th century, any thoughts about what made that happen? You know, what was the environment that made all these people emerge?
Well, that's practically another lecture, Stuart, but it's really an interesting thing. I think people tend to think of the Commonwealth as being rather dour and Cromwellian and uninteresting, and the Restoration was where it all happened. But actually, Cromwell was quite interested, and he was very encouraging to all these people. I mean, I think it had been building up for some time. So you'd got on the continent, there was Descartes and Bacon. In Britain was Bacon, and the movement had been growing. Dissatisfaction with the old status quo, where what you thought was more important than what you saw and did. People were realizing that had severe limitations, and I think I've sometimes wondered, how do you get Wren, Hooke, Newton all at the same time? But maybe if you look back in 100 years to this period, the last 100 years, you might see, how did you get Einstein? And I can give you half a dozen chemists who have done stellar work, so to speak, and astronomy, it's all moved. These things tend to happen in clumps, I think, because, well, I mean, I worked in universities, and I know the most stimulating was where I was surrounded by colleagues who were stimulating. And I think that period at Oxford just happened to have people with a lot of ability, and to gather people together like that. That was why they formed the Royal Society, because they wanted to discuss, and they spent their entire days doing it. They had the means to do so. So it's not a very satisfactory answer, but it's the best I can do at the moment. And Charles II, of course, continued that. He had a great interest in science. Quite why is another question as well.
Thank you, Alan. That's a very enjoyable talk. I really thought it was great. Do you think his legacy was diminished by being so broad, being a polymath? I mean, we've often discussed John Herschel. Yes. His legacy was, I think, diminished by the fact that he did great things in many different areas. And, if you're known for just one or two things, it's much easier to be remembered through history. And I think we should look again at the polymaths and see what their integrated effect on development of knowledge was.
I think that's very perceptive, yes. It depends what you want from him. If you want him to be sort of seed corn for many intellectual activities and helping people to think differently, then being a polymath helped the development of science. But for his own particular reputation, I think it did diminish it, because he had a mind that seemed to jump. He would do 6 things in a day, or 6 things before breakfast, quite probably. And he had that sort of mind. If he'd focused on gravity and light in competition with Newton, he might still have been diminished, because Newton had the maths. But if he'd done other things, if he'd stuck with microscopes and looked at the living world and tried to see yes, I think he could have had a bigger legacy personally, but whether the world would have a bigger legacy, I think it's a fascinating topic to look at, yes.
I've got a related question, actually, and that is about, and also connects to John Herschel, the issue of a lack of a portrait.
Yes.
I mean, people in those days often had portraits as a way of promoting their image, like
yes.
having a website and so on. So my question is, what we do know about his ego? Some scientists, and John Herschel is a case in point, were very keen to help other people, but not particularly concerned about their own reputations. Others, like Newton, were about the other end of their spectrum. Well, where would Hooke stand?
I think Hooke would come in the middle of that. He did have sensibility about his own achievements. He did get cross when people questioned them, but in terms of his legacy, he didn't really make very much effort. He was just so consumed with the day-to-day. Yes, I think the parallel with John Herschel is actually quite interesting one. I've got much more to say on that, really. But, yes, it's an interesting point.
You mentioned that many of us studied Hooke's law in school physics. When did he do that work, and when did it come to be known as Hooke's law?
I think it only became known as Hooke's law towards the end of his life, when people started calling it that. I can't remember the exact date he did it, but what people did in those days, really rather strangely, they sometimes announced findings in code, and he had some sort of code which, when people managed to crack it, said something like ut extenso sic vis, something like that, which means as the extension, so the force. But you had to work it out to get there. I'm not quite sure why he did that. It was one of his early experiments because it arose from his studies with watches and springs, but also his studies of elasticity, which he did with Boyle. So it was pre-1660 was Hooke's law, and it only became known as that much later.
Right. We have a question online from Stuart Reynolds, who's the convener for the BRLSI Science Group, and he asks, what do we know of Hooke's religious opinions? Was this relevant to his originality in science?
Yes, I've skipped that because I'm uncertain. I find he was son of an Anglican curate, and there's no mention of going to church in his diaries. In Micrographia, of which you can get, there are numerous copies of it. This is a facsimile, but about a tenth of the size, so very difficult to read. In Micrographia, I think he has two separate formulations. He talks about the Creator once or twice. Why did the Creator do this? Which suggests that he did have some sort of fundamental belief in a God. But most of the work that he's talking about, the natural phenomena, he calls nature. And I think that's quite an interesting distinction between the two. And I haven't quite worked out the significance of it. But I don't believe he had strong religious opinions.
Do we have...
Was Newton's cradle invented by Hooke? Or
Was Newton's what, sorry?
Newton's cradle.
Oh, yes. Many people believe that Hooke invented Newton's cradle. There's quite a lot of things that Hooke invented that are called, there's a sound wheel, which has got lots of tooths all around it, and you spin it around and put a vibrating piece of metal on it, and it makes a sound. And I've forgotten, some Frenchman's claimed that, but Hooke invented it, and he claimed that he could measure the frequency of the sound of a fly's wings by using this. But yes, there's no definitive proof who invented Newton's cradle except that it wasn't Newton. And it was probably Hooke.
Good evening. I'm interested in the education and especially his attitude to mathematics. He seems to have ended up as a sort of craftsman, engineer, inventor without being able to do the maths as Newton told him, or substituted the maths for what Hooke was doing. So was he failed at school and at Christ Church in some way, or did he just not concentrate on the mathematical side?
No, it's an exaggeration to say that he wasn't very good at maths. He probably could have been a professor of maths now, and the ability that he had with mathematics, but it wasn't equal to Newton's. Newton required all sorts of new maths to work out an elliptical orbit, and Newton was the only person on the planet who could do that. I mean, he really was. There was Leibniz later with his calculus might have been able to do, well, Leibniz and Newton's calculus were about the same time, but he actually solved it using some conventional maths. And Principia Mathematica, interesting, just an aside here, but Principia is designed by Newton to satisfy himself and to prove to the rest of the world what a genius it is. It's written in Latin. There's a cartoon from the time when Newton's going to give a lecture and a student saying, "There goes the man that wrote a book that not even he can understand." Whereas Hooke was much more interested in in doing things. But he was very adept at maths, and it's quite probable that he did the maths that supported intellectually the dome of St. Paul's that Wren designed, but Hooke actually made sure that that was a structure that was going to hold, and he did the maths on that. So, yeah, he was a good mathematician, an excellent mathematician, but not a brilliant mathematician.
Thank you very much. Correct.
Well, not a correction, just a comment.
No, I shot away with the wrong impression.
All right. That's my fault.
Right, on the chat channel we have, earlier you said he was friendly and well liked up until the end of his life. What happened at the end? Towards the end?
There were two very sad events. The first was that Grace died of smallpox. Forgotten the year, but that was like 1682 or something like that. Grace died, and that absolutely floored him and really sent him into spirals of depression, and his irascibility increased. But also, he was worn down by the disputes with Newton. I'm going to say, I said two, I'll say three things. Worn down by Newton. And the third thing was his health deteriorated quite a lot. Towards the end of his life, he was blind and in great pain. And so as that was approaching, Grace had died, Newton was wearing him down, and he wasn't such a hail fellow, well met as he had been. So there were, that was a sad end to a brilliant life, really.
Thank you so much for a great talk. I wonder if you could talk a little bit more about the zeitgeist. So all of these great people, all these giants and
Yes.
the people standing on the shoulders lived through the English Civil War. It was a period that at the time was called the world turned upside down.
Yes.
They recognized it as a really fundamentally revolutionary change. How much do you think this was a really decisive influence on the freedom of thought that they then enjoyed?
Fantastic question. And again, a whole lecture, I think, about I did suggest that we might do something on the formation of the Royal Society in that period as a kind of a day here at some time, because there's so much to learn from it. The people that were unusual, nowadays one doesn't necessarily associate aristocrats with great thought and, shall we say, whereas there were actually, it was a period when freedom of thought, as you said, was becoming, for the upper classes, was really being encouraged. And although women scientists have always been, had to fight very hard to get where they are, there were two wonderful women scientists in this particular time. One was Margaret Cavendish, who was part of the Cavendish family, and she was a scientist, and the other was Lady Ranelagh, who was Boyle's sister, and Hooke lived with her for a couple of years before he became professor at Gresham, and she had a laboratory built in her house. So there was a big encouragement to think differently. And as I said in answer to an earlier question, this was a time when the world was being turned upside down. And I find it quite difficult to understand quite how, but that's why I put up that slide with 5 kings and a queen, because they managed to weather being, some of them were Catholic, some of them were Protestant, and they managed to weather it all. Oxford at that time was a very closed intellectual society, and it was only later when it expanded out to the Royal Society and to London. And Newton, of course, was Cambridge, and he stayed there for most of his life. So I think it's really, why should they be encouraged. They were people of means. They had a curious, a natural, or not natural, they had curiosity that had been developed through their education. I mean, this was the time when many of them went to Eton, Westminster. They were starting to go to public schools, which were very keen on encouraging learning, and instead of being homeschooled as they might have been in the past. So a lot of social factors were coming together to bring them into a period when intellectual activity was valued as well. That's the difference. Experiment was valued. Tinkering around with things, people loved it. I mean, I think you need a sociologist really to answer the question better than me, but it's certainly what's fascinated me about the period, the turbulence of the period together with the not just steady but cataclysmic advance of science. I mean, just pouring things, inventions. I mean, if you think all the people I put up there at school, we learned Boyle's law, we learn about Halley's comet, we learn about Hooke's law, we learn about Wren, we learn about Newton's laws, you know, all from that period. And they're still pre-quantum mechanics anyway, they're still the foundations of a mechanical universe. So I think it was social factors conspired.
Stuart Reynolds again asks, did Hooke travel abroad? I'm interested to know whether he could have met other early microscopists like van Leeuwenhoek, who were alive at the same time.
No, I don't think he ever travelled abroad. He wasn't really robust enough, but he loved the sea, being from the island. He loved the sea. Leeuwenhoek did most of his work just after, he did most of his great work after Micrographia was published. He used a different microscope. He actually used a sphere, a glass sphere, and he used that to look at his tiny little things on a little holder. But I don't think they ever met. I think they corresponded once or twice. He corresponded a lot with people abroad, but he didn't, because of course, when the Commonwealth came, a lot of royalists actually went abroad. I mean, Hobbes was one of the famous ones, but everybody hated Hobbes. And he went abroad and came back, and the Royal Society refused to have him as a member, and despite Leviathan and all this. So, no, he never travelled abroad. I think he did travel to Bath, but I've been unable to track down where he travelled to. He designed a house for Mr. Montague, who was one of the Montague Bewley families, and this is it. These are this is the gatehouse. It was the biggest house in London, and this is it. And it was formed where the Royal Society, where the British Museum is now. And although he never travelled abroad, he rarely travelled in the UK as well, apart from to the Isle of Wight and back. But in his diaries in 1672 or 4, he's got a rather gnomic entry that says, at Bath with Mr. Montague for 2 days. And there is a house called Northumberland House in Bath, and Montague married the Countess of Northumberland after her husband died. So I'm guessing that it was at Northumberland House that he stayed, and that's now called the Grapes. All right. So no, he didn't go abroad as far, although he did help with the harbour at Tangier. He did some designing for that, but he didn't go there.
Thank you for a great lecture. Just a quick question on what was the root cause of this animosity between Newton and Hooke? Was it jealousy, rivalry, or was it simply personality clash?
All of the above.
Everything?
Yes.
Religion too? Was religion
Yeah,
included?
but the main reason was that, as I said, Newton would brook no argument, and Hooke argued with him. So Newton wanted to destroy Hooke's reputation, and Hooke went into absolute paroxysm of fury because when Newton published various papers on light or gravity, he definitely avoided the mention of Hooke, whereas there is plenty of evidence that Hooke had written to him on the subject, told him what he was doing, suggested that they correspond. So on Hooke's case, it was because Newton wouldn't recognize him, and on Newton's case, it was because Hooke was an irritating little tick.
Right. Well, there are no more questions online, and I think we've come to an end in the room. Well, now speaking for myself, I'm yet another one who thought, well, there's Hooke's law, and I know Hooke is very important for other reasons, but I don't really know what they are. And I'm really pleased to have been enlightened this evening, and also to have learned about the connections between Hooke and these other important people. So let's thank Alan Bassindale for giving us such a good lecture.
Thank you very much.